Hello everyone. So in section 4.4 we learn how to make a guess for a particular solution. But I hope you can remember that I said we still didn't solve a full problem. But before we go to solve a full problem, we have to sharpen our algebraical skills of solving equation for some unknown constants. So let's look at some examples. So here in example 1, you can see a very complicated equation. And guess what you have to do? You have to solve this equation for capital A, capital B and capital C. Those are constant. Now you can see why I'm trying to give you a practice of this, because when you guess a particular solution, you would have unknown constants, right? A, B, C. Now how are you going to find them? Well, if you have a complementary function C1 and C2, you know you can find them using initial conditions. But then how to find these A, B, C, D's in the particular solution? Well, once you use the methodology, you will get an equation like this. Let's learn how to solve this type of equation. Now the secret is, when you use the method, you will get an unorganized version of an equation. If you look at this left hand side, everything is all over the place. So the key is to reorganize your left hand side. Reorganize, group the similar terms. Okay, what do you mean by grouping similar terms? Look at your right hand side. You have x square terms, you have constant terms, you have exponential terms. So accordingly, in the left hand side, try to group the x square terms together. So what are the x square terms we have on the left hand side? Just this, right? Let's see. Yeah, 9ax square. So let's write it first. Okay, so that's the only single term. Good. Then try to look at both left hand side and right hand side. Okay, so if you look at left hand side, you have x terms, right? So try to group x terms together. So we have x term here, we have x term here. So we can write negative 12ax plus 9bx. So we write them together. That's the secret. Okay, if you do it correctly, you are likely to get good results. Okay, now the next thing is then we have exponential terms. The order doesn't matter. Okay, so let's pick up the exponential term. That's the only exponential term on the left. So 2e to the 3x. Then the rest is just constant terms. Well, they were already together. So we rewrote the left hand side according with a nice organized way. Okay, good. Now try to do a factorization on the left hand side if you have similar terms. So here this is the only single term, so I would write 9ax square. But what I meant is, here you have two terms of the coefficients of x, or x terms. So I would factor out a x there. Okay, so plus negative 12a plus 9b times x. So I group them. Now I factor out the common terms in the similar category. Okay, plus 2e to the 3x plus 2a minus 6b plus 9c is equal to this right hand side. Okay, so now how are we going to solve this? Remember, finding A, B, C is our final goal. Okay, all right, this is second example, this is third example. We'll get in there later. Okay, so now once you group them, the secret to solving for A, B and C is to compare left hand side and right hand side. Now why did we group them? The whole purpose of group them is, think you have x square terms on the right. Shouldn't that be equal to exactly the x square term in the left? So left hand side similar term should be same as the corresponding right hand side terms. So 9ax square should be same as 6ax square, or the coefficients of x square should be same. So actually 9a should be equal to 6. And that is how you find A, B and C. So A is actually 6 over 9, which is actually 2 over 3. Okay. Now to find B or the other ones, well, I can use this. coefficient of x. So the coefficient of x on left is negative 12a plus 9b. Coefficient of x on right is, well, you don't have x on the right hand side, so there's no coefficient, so 0, right? Actually there is coefficient, it's 0 times x is 0, but that is 0, right? Okay, now we already know a. Can't we find b? Yes. So 9b is actually 12a when we take a to the other side, so b is 12a over 9. Now I'm not going to find what is a in numerically to save time, okay, but that's the procedure, okay? The goal of this video is to tell you the procedure. Now here we can find e using comparing the coefficients of exponential. So here the coefficient of e to the 3x is 2e, right? So 2e should be equal to the coefficient of ex on the right, which is negative 12. Don't forget the negative sign, okay? Negative 12. So e is negative 6, right? Now one letter left. So how can we find c actually? Well, it's easy, right? Now you compare the constant terms. So you can see we already know a, we already know b. So plus 9c. So 2a minus 6b plus 9c is the left hand side term, constant terms. What are the constant terms on the right hand side? Just 2, right? Just 2. So we already know a and b, so we can find c, right? So that's the idea. Now it gets a little bit tricky when you move on, okay? Let's look at another simple example and move on to something tricky. Now here, well, let's regroup them. Well, here we don't have to regroup, right? Here we have x terms, here we have sine x terms, here we have constant terms, here we have cosine terms. Okay, so they are already in an organized manner. Okay, all right. So if you compare the coefficients of x terms, you can all of a sudden see a is 4, right? Okay, if you compare sine terms, coefficients of sine, negative 2c on the left, on the right you have 10, so c is negative 5. If you compare constant term, here on the left we have b, just b. On the right you don't have single constant term, right, isolated, but we do have it's 0, right? So b is 0. So on the left you have coefficient of cosine is 2e. On the right you don't have cosine, 0, so e is 0. So that was a rather simple example. Let's look at a complicated one. Now here, not complicated, okay, different type of one. Now here we have cosine and sine. So let's group sine together, cosine together. So where do we have sine, cosine? So let's start with cosine. So this is a cosine term, this is a cosine term. So let's write them together. Negative a cosine 3x minus negative 3b cosine 3x. And let's write the sine terms together. So 3a sine 3x minus 8b sine 3x is equal to 2 sine 3x. Okay. All right. So now here I can factor out a cosine term. So negative 8a minus 3b cosine 3x. Yes, this is a very good example. Now let's factor out a sine x here. Why do we factorize? Because there are two similar type of terms. So we can get one when we factor out, so that we can compare coefficients nicely, right? So this is equal to the right. Now using the coefficients of the cosine, here the left it's negative a minus 3b, on the right it's 0, right? So you can see all of a sudden we cannot figure out a and b by one shot. So let's keep it, okay, let's keep it. But then using the coefficients of sine, 3a minus 8b is equal to 2. That's the second equation. All right, so we get two equations rather than directly getting answers for a and b. Now guess what you have to do? You have to solve this simultaneous equation pair, right? So let's see what we can do. The secret of solving this problem is trying to make the coefficients of a one constant value same with the opposite sign. So here you have 8, here you have 3. Let's multiply the first equation by 3. Okay, so when you multiply the first equation by 3, you get negative 24a minus 9b is equal to 0. 0 times 3 is 0. So let's call this equation 3. Let's multiply the second equation by 1. 8. Why do I multiply by 8? 8 times 3 is 24. So we get 24a, the same number but different sign. So we can cancel out a. Okay. So 8 times 8, 64. So 64b. 8 times 2 is 16. So this is the fourth equation. Now you can see when you add the equation 3 and 4, these two terms cancel out. So negative 9b plus negative 64b is negative 73b. 0 plus 16 is 16. So b is ugly number, 16 over negative 733. I shouldn't say that as a mathematician. A beautiful number. Okay. All right. So b is this, 16 over negative 73. Now how can you find a? Well, now you have two equations. Use any equation you like here. Okay. So negative 8a minus 3 times b is now 16 over negative 73 is equal to 0. So this is negative 8a minus positive 3 times 6, 8 is 48 over 73 is equal to 0. So let's take this term to the right. Negative 8a is negative 48 over 73. Now divide by 8. Negative 8. So negative cancel out. 48 divided by 8 is 6. So 6 over 73 is a. Okay, so that's a one scenario that can play out. When you equal the coefficients, you can get simultaneous equations. Then you have to solve them too. All right, so I think we covered up the algebra. Do the next quiz with the algebra, and then we can finally see how to solve a full problem using method of undetermined coefficients. See you in the next video.